Hi everyone, welcome to our second science lesson on forces for this term. Last week was just an introduction, and this week we're going to be thinking about gravity and mass and weight. Now, hopefully you should have watched the video about Sir Isaac Newton. I hope you enjoyed the fact that he had long curly grey hair at the age of 10 years old. I think the authors of the video didn't quite manage to think about that fact. So that was a recap of Isaac Newton creating gravity and Isaac Newton discovering gravity, which hopefully you already knew. So just a little recap. The Earth and the Moon both have a gravitational pull. So in the centre of the Earth and the Moon, from the core, there is gravity which sort of radiates out and it pulls things and keeps them on the surface. And it's the reason that we don't float off. It's non-contact force because it pulls us in, but there's nothing physical exerting itself on us, physically touching us. It's just the force which is pulling us in, kind of like a magnet. Now, the gravity on the Moon is very low compared to the gravity on the Earth. So different planets have different levels of gravity. So the gravity on the Moon is only about 17% of what we have on Earth. So if you went to the Moon, then you would be floating off, hence why you see people there who have to wear spacesuits to keep them grounded. Now, the size of the force of gravity depends on the object itself. So smaller, lighter objects will have less gravity pulling down on them, and larger objects will have stronger gravity. So someone who is very small will have less gravity pull them down. So if there was less gravity, they would float up more. And larger objects, so somebody who was bigger or taller, would have more of a pull of gravity. So what is weight? Weight often gets confused with mass. Weight is actually the pull of gravity on an object. So as said before, the more matter an object has, the more atoms it has, the more gravity will pull on it. But your weight can change according to where you are. So your weight on the Moon would be different than your weight on the Earth, because on the Moon, there would be less gravity pulling you down. So your weight would be less on the Moon than it would be on the Earth when you have more gravity pulling you down. So what is the difference between mass and weight? Now, as I said, we often get confused and we say, how much does it weigh? And actually, we want to know the mass of something. So, the mass we can measure by the number of atoms it has or the amount of matter in an object, and it's constant. So your mass, wherever you are in the universe, stays the same. To measure it, say we use a beam balance. We'll get there, guys. It's all part of the fun. So to measure mass, we use a beam balance. So we use scales that we have in our kitchen. We use scales that we have in the bathroom. We have them where we put something on either side to weigh it down. And we usually measure mass in kilograms, grams, but we can also measure it in pounds, ounces, and so on. Now, weight, as I said before, is the force exerted by an object due to gravity. So it's about how much gravity is pulling it down. Now, our weight is not constant. So your weight is different depending on where you are. We measure weight using force meters usually, or Newton meters, which I'm going to show you a picture of in the next slide. And hopefully you've used them before at school. And we measure it. The units of force are newtons or kilogram force, where 1 kilogram force is about 9.8 newtons, but normally we say newtons, and obviously that is named after Isaac Newton. Now, as we can see, measuring mass, we use different types of scales, and measuring weight, we use these things called Newton meters or force meters. And how it works is that you put an object on the end here, and gravity pulls the object down, and hence the spring gets pulled down, and this little marking here shows us how many newtons it is. So the more it gets pulled down, the further this moves down, and the more newtons something is. We call this a spring force. And this one works in a very similar way. It pulls down and it shows us how many newtons we have. Now, on Earth, we can convert roughly between mass and weight because our weight is roughly consistent on Earth, although it would vary depending person to person. But if we want to generalize, which we are going to need to for our activity, then we can say that 1 kilogram is the same as 10 newtons, or if we simplify that, 100 grams is the same as 1 newton. Obviously on the moon this would be completely different, but for today's activity we're estimating that a kilogram is the same as 10 newtons, or 100 grams is 1 newton. But as I said, this would vary depending on where you are and how heavy you are. So, for today's activity, you should watch this YouTube video next, which is by a teacher called Mr. Dyson, showing you how to create a Newton meter. The things that you will need to make your own Newton meter. So obviously if we were at school you would be using one, but we're not at school and we haven't got them at home, so we're making our own. We're getting creative. So you need to start with something like a clipboard, a piece of card, a bit of paper against a wall, something that you're going to be able to hang a paper clip off and that you're going to be able to write on. So you need 2 paper clips, one that's going to hang off the top and then another one that's going to go underneath your elastic band here. Now, you could use, instead of an elastic band, you could use a hairband. And if you don't have paper clips, you could always use a safety pin, a bit of wire, something bent. Basically, you just need to create some sort of contraption like this. Now, once you've done this, you can mark 0 newtons on your piece of paper or board because there is no object on here at the moment, so there is no force pulling it down. Therefore, where the bottom of this paperclip hangs is 0 newtons, okay? And that's what you need your pen or pencil for, to mark on 0 newtons. There is no weight being exerted on anything because there is no object. Then the next thing you need to do is find an item which weighs around 100 grams. So you're going to be able to do that by, you could look at food items in your kitchen and it might say on the packaging that they're 100 grams. Or you're going to have a bit of a go with some different things and you need to get some scales. Hopefully you have some, either kitchen scales or bathroom scales. If you don't have any scales in your house, then you need to send me a message so I can help you out with what to do instead. And you should need to find out roughly something that is 100 grams. When you have found this thing that's 100 grams, you need to hang it onto your Newton meter. Mr. Dyson uses a weight, but you probably won't have a weight. So you hang the thing that's 100 grams, and then we're saying roughly that is the same as what 1 Newton is. So then you mark on your bit of paper 1 Newton. Okay, then you need to find an item that's 200 grams. So you could use 2 of the thing you had before, or you could find something else that's 200, hang it onto your Newton meter, and now you can mark what is 2 newtons. Okay, so you should roughly be able to now see what 0 newtons, 1 newton, 2 newton. Now, obviously this is not exact, and it's not like you're going to be able to read exactly, but it's giving us a rough estimate of how many newtons something weighs. Now, once you've done this, you need to find 5 items in your house which you are able to hang onto your paper clip or whatever you've got hanging. This could be a pair of sunglasses, some keys, a pair of scissors, something that will hang. Then you have to hang it onto your paper clip. Mr. Dyson did his keys. And you need to see where does the bottom of your paper clip go to. So the bottom of his paper clip is roughly halfway between 0 and 1 newton. So he can estimate that his keys weigh 0.5 newtons. Now then, if he goes to measure the mass of his keys using scales, he might then find out actually they're 46 grams. So obviously this is a rough estimate. So you then need to weigh your 5 items using the Newton meter, and you also need to measure their mass using your scales. Then in your book, you're going to write the date and the LO and thud. If you've got your science book, you can use your science book, but I think most of you have got your topic books. Then you're going to draw a table with 3 columns, one for item, one for mass, which you're measuring in grams or kilograms, and one for weight, which you're measuring in newtons. Then you're going to put the item, how much the mass is, and how much it weighs. Now, your Newton readings are obviously going to be estimates because we are using our homemade Newton meters, but the mass of your item should be read accurately to the gram from the scales. And if you need help reading the scales, then ask an adult to help you. This work is not due in until Wednesday, and I've given you the extra time so that you can do it in an evening with an adult if you're going to need help to create the Newton meter, or if you need help using the measuring, or if you need help finding things that are 100 grams. So when you've done that, you should take a picture of your finished work and a picture of your Newton meter and put it on Seesaw. If for some reason you're having any big problems, then just let me know and I can try and help you out. If you don't have any scales, then the best thing for you to do is to find items in your kitchen which have amounts already written on them. So you'll see on different food items, it will tell you how much they weigh, and you can use that to create your Newton meter. You just won't be able to measure their mass exactly in grams on scales, but you'll still be able to fill in the table using the amount on the item that's marked on the item from the packaging, and you'll be able to weigh it using the Newton meter. I know it's not necessarily the most precise or easiest task, but we've got to get creative as we can't use all the things we have at school. So have a go, and I hope you have fun creating your Newton meters. And the idea of the lesson is that you need to understand the difference between mass and weight. So mass is the amount of atoms something is, and it is constant, and weight is the number of newtons, and it is how much gravity is exerting on us, and our weight changes according to where we are and also how heavy something is. Okay, good luck everybody.